Hi everyone, this is a recording of the Math and Robotics workshop held on December 2023. Mission Math and Sushi Squad partnered to hold this workshop. During the workshop, we split into three groups. The beginner group, which goes over basic algebra application in robotics, advanced group 1, which is the one I'm recording right now, and is about how geometry is used in robotics, and finally, our final group, advanced group 2, which goes over 1D kinematics and its applications in robotics. The other two, the beginner group and the advanced group, are already recorded and on our YouTube channel on Mission Math. So let's get started. The applications of geometry and software in robotics. Okay, so welcome. We are going to cover basic geometry, SOHCAHTOA, which I'm going to review and go over in a little bit, special right triangles, applications of trig in robotic software, and we're going to go over a bunch of practice problems. So just have a paper, a writing utensil like a pen or pencil, and a calculator ready. Okay, so starting with trigonometry. Trigonometry is the branch of mathematics dealing with the relationships between the sides and the angles of a right triangle. Okay, so remember that right triangles are any triangles with an angle of 90 degrees. And this is symbolized by this square in the corner of the triangle right here. And some of the properties of right triangles are that the interior angles add up to 180 degrees, and similar right triangles have same angles and directly proportional side lengths. And basically what this means is that if we know just one angle measure, for example, if we just know the angle right here, then we know the ratio of the lengths. So we know the ratio of this length to this length, we know the ratio of this length to this length, and we know the ratio of this length to this length. And using just one angle measure and one side length, or three side lengths, we can solve for the remaining side lengths and the angle measures. So if we know this and this, for example, if we know the values of both of them, then we can solve for everything. So we can solve for this angle right here, we can solve for this length right here, and we can solve for this length right here. Or if we have three side lengths, for example, this length, and this length, we can solve for all the interior angles, all the angle measures inside. Okay, so let's go over some basic terminology. So this length over here is called the hypotenuse. And this side is always called the hypotenuse because it's the side opposite to the right angle. So this is the right angle right here, as I said before, and this is the hypotenuse. No matter how the triangle is oriented, even if it's oriented like this, for example, and the 90 degrees over here, this will always be the hypotenuse. Always the angle, always the side directly across from the 90 degrees. Okay, and we will refer to the side opposite to the angle, opposite, and the side adjacent to the angle, adjacent side. So this, for example, is the angle, and we call this letter right here theta. Theta is a Greek letter, and it's used for an unknown angle measure. So over here, as you can see, the side opposite is the it's called opposite, and the side adjacent is called adjacent. Okay, so let's go over some rules and the SOHCAHTOA thing I was talking about. So first there's sine, which is opposite over hypotenuse, and I'll actually go over more of the SOHCAHTOA and how exactly it's used later on. But let's start with the ratios. So sine is one of the ratios, and it's opposite over hypotenuse. So opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. Okay, so let's do some practice now. So we have sine theta, cosine theta, and tangent theta here. I want you guys all to try these out. And then you can go back about like 5-10 seconds in the video if you're confused and if you can't remember what the ratios are. But just try to do it off of memory at first, because it really helps build those neural pathways and all, and helps you learn it a lot better. So you can pause the video and try these out, and then I'll review them. Okay, let us review them. So check whether you got these correct. Sine theta is 4 over 5, cosine theta is 3 over 5, and tangent theta is 4 over 3. So let's go over why these are. So this is theta right here. So that's not a good color. Let's make it a little bolder. Okay, this is theta over here. So this is the angle which we're comparing everything to. So the side opposite is 4. Let's just label this opposite. The side adjacent is 3, adjacent. And 5 is the hypotenuse because it's directly across from the 90 degrees. Okay, so recall that sine theta is opposite over hypotenuse. And opposite here is 4, so we do 4, and the hypotenuse is 5, so we do 5. Cosine theta is adjacent over hypotenuse. And this is equal to adjacent 3, 3 over hypotenuse 5. And then finally tangent theta. Tangent theta is opposite over adjacent. Adjacent. And this is 4, side opposite, over 3, side adjacent. Okay, let's do one more set of practice. So as you can tell, the triangle is oriented a little bit oddly, but don't let that confuse you. Use the 90 degrees as your reference point, and then solve for all these ratios: sine theta, cosine theta, and tangent theta. Pause the video as you work through them, and then I will go through them, review them after you're done. Okay, let's get started. Let's first mark out theta, make it obvious. Theta is over here. The side opposite is 8. Let's label that. The side adjacent is 15. So let's label that. And the side opposite to the hypotenuse, I kind of gave it away there, but the side opposite to the 90 degrees is the hypotenuse, which is 17. Okay, great. Now let's solve for the ratios. So sine theta is opposite over hypotenuse. So therefore this must be opposite 8 over the hypotenuse 17. Cosine theta is adjacent over hypotenuse. So that must be adjacent 15 over 17. And tangent theta is opposite over adjacent. Adjacent. So therefore that must be opposite 8 over 15. Okay, great. Now let's check our answers. Okay. That's correct. Oh, yeah. They're all correct. Great. Okay. Okay, so this is a really, really easy way to remember the ratios. I still use this right now, and I'm in calculus. So this is the go-to way for me to remember it. So katoa. So is sine, and then opposite over hypotenuse. SOH. So, and then ka is cosine over cosine equals to adjacent over hypotenuse. Ka. And toa is tangent equals to opposite over adjacent. So if you remember this, you're solid. Just genuinely try to memorize this, and then you're good for the rest of rest of math you learn. So remember, just so ka toa. Sine equals to opposite over hypotenuse, cosine equals to adjacent over hypotenuse, and tangent equals to opposite over adjacent. Okay, let's go over some special triangles. So some of the special triangles we have here are the 30, 60, 90 triangles. So this 30, 60, 90 are all degrees, 90 degrees, 60 degrees, and 30 degrees. And there's specific ratios for this that are also really easy to memorize. So for the 30, 60, 90 one, the side opposite to, let's go off the 30 degrees in this case as a reference. So let's label this theta. So if theta is 30 degrees, then the side opposite opposite would be x. X is just variable, right? And this is the value we're basing everything off of. So then the side adjacent to it, remember that theta is 30 degrees and that is our reference angle in this case. Adjacent is x root 3. And then hypotenuse is 2x. Hypotenuse equals 2x. Okay, so 45, 45, 90 triangle. This is an isosceles triangle, as you can tell, because two of the sides are equal and two of the angles are equal. So let's see. The side, let's use this 45 degrees. And honestly, in this case, it does not matter. Like, you know what the sides will be as long as, because both the angles are the same. So then the side opposite and the side adjacent will be the same value. So it'd be x and x, no matter which side you go off of. Opposite equals to x, adjacent equals to x. Hypotenuse, side opposite to the 90 degrees, is x root 3. X root 2, sorry. X root 2. These are not necessarily you have to memorize them, but it's definitely extremely helpful to memorize them. And we'll get to use them in the following slide. Okay, so let's do some practice with special right triangles. So I want you guys to start by trying to figure out the side lengths. So let me just label them here for you. A, this side over here. B, change the color here so it's a little easier to see. B, and then I want you guys to also figure out the ratios. So let me label those as well. What sine 30 degrees is, what cosine 30 degrees is, and what tangent 30 degrees is. Okay, you can pause the video and go back if you need to. However, I would suggest, once again, trying to do it off your memory because it helps you learn it better. So just pause the video right now and work on it, and I'll review it in just a second. Okay, let's start reviewing it. Okay, so let's start with figuring out the side lengths. So we see here that 8 is the hypotenuse. It's a hypotenuse because it's right across from the 90 degrees, from the 90 degree angle here. So we can label, in this case, let's label this C. C equals to 8, and 8 also equals to hypotenuse, right? So then if you remember the ratios for the 30, 60, 90 triangle, remember that one side's 30, one side's 60 degrees, and one side is 90 degrees. And then this is x root 3, this is 2x. So the side adjacent to the 30 degrees is always x root 3, and the side adjacent to the 60 degrees is always x. And the hypotenuse is always 2x. So now that we know that 2x is the hypotenuse, and the hypotenuse is also 8, that means that 8 equals to 2x. And we isolate the variable. Oopsie daisies. Divide by 2, you divide by 2, and you get x equals to 4. Okay, so since x equals to 4, and x equals to the side adjacent to 60 degrees as well, or you can also call the side opposite to 30 degrees, A, because it's the side opposite, you can see here, side opposite to 30 degrees, A is 4. So let's just label A as 4 over here. A equals to 4. Okay, so now let's move on to B. B is x root 3. And since x is 4 and B is x root 3, B equals to 4 root 3. Move that just up there. See daisies. X root 3 and B is 4 root 3. Okay, great. Now we have all the sides. And since we have all the sides, we can do the ratios now. So let's start off with sine 30 degrees. Sine 30 degrees, if you remember, so sine equals to opposite over hypotenuse. Opposite here is A. and hypotenuse is C. So A is also 4, so you do 4 over C, which is 8. So you get 1/2. Okay, now let's move on to cosine. Cosine 30 degrees is if you remember cosine equals to adjacent over hypotenuse. Adjacent is B, and B is also 4√3. So 4√3 over the hypotenuse, which is 8. So you cancel out, and you get √3 over 2. I'm going to make this a little bit more clear after we figure out tangent 30 degrees. Okay, so tangent 30 degrees. TOA. Tangent equals to opposite over adjacent. Opposite, A over adjacent B, A over B. A is 4, B is 4√3, so then you just cancel them out, and you get 1 over √3. So this answer also works, but generally what you do here is you rationalize the denominator, which is basically where you want to take the square root out of the denominator, because it's not proper, I guess, and it's not simplified correctly. So what you just do is you multiply the square root on both sides, so on the numerator and the denominator, not necessarily, yeah. Oh wait, that's 2 times √3. So you get 1 times √3 on the numerator, so you get √3. √3 times √3 is 3, so you get √3 over 3. Okay, let me just highlight them to make it a little easier to tell. Okay, so tangent 30 degrees is √3 over 3. And cosine 30 degrees is √3 over 2. And then finally, sine 30 degrees is 1/2. Okay, now let's check your answers. Okay, great, they're all correct. I know it's a little bit hard to see, but A equals to 4, B equals to 4√3, C equals to 8. Sine 30 degrees equals to 1/2, which is what we found over here. Cosine 30 degrees equals to √3 over 2, which we found over here. And tangent 30 degrees equals to √3 over 3. Okay, now there's one more practice problem after this, so I'm just going to erase everything. Okay. Okay, great. Let's move on to the next one. Okay, now I want you guys to do this. Pause the video, whatever you need to do, and then we'll go over it. Okay, let's get started. Okay, so this time we have a different side that is given to us. So what we can do here, let's label each of the sides first. So this is A over here. Oh wait, that's really bad. Okay, A over here. Oh, that's not right color. Okay, A over here. And this is also the side opposite to 30 degrees, so let's also label this opposite. And it makes it a lot easier if you label each of the sides A, B, C, or opposite adjacent hypotenuse. But just remember which angle you're referencing. So in this case, we're referencing the 30 degrees over here when we talk about opposite and adjacent. Okay, and then this over here is B, and this over here is C. Okay, let's start with solving for each of the sides. So we know that A equals to 5, right? Let me just make that a little bit more clear. A equals to 5. And then, remember from the 30, 60, 90 triangle, actually, I'll just label it here. Let me just erase this 8 over here. Okay. So if you remember from the 30, 60, 90 triangle, one side, so this is also 60 degrees. The side adjacent to 30 degrees is x √3. The side adjacent to 60 degrees, or as you can say opposite to 30 degrees, is x. And these triangles are not proportional. What I mean by not proportional is they aren't actually 30 degrees. Like if you measure this angle over here will not be 30 degrees. So never, as a general rule of thumb, never go off of the given diagram. Go off of the angles and the measurements you have been given. Okay, so and then the hypotenuse is 2x. Okay, now let's use these. So 5 equals to A, and A is also adjacent to 30 degrees, which is x. So A equals to x, which also equals to 5. So we know that x equals to 5. Okay, from there it's really easy. C equals to 2x, right? So then we go back and we see 2x, x is 5, so 2 times 5 is 10. Okay, great. Now let's move on to b. So b is x root 3. X is 5, so it's 5 root 3. Okay, now time to move on to the ratios. Sine, cosine, and tangent. Okay, let me just label these up here. Sine 30 degrees, cosine 30 degrees, and tangent 30 degrees. Okay, let's see. So sine is opposite over hypotenuse. So opposite is 5. So we do 5 over hypotenuse, which is 10. And this simplifies to 1/2. I'm going a little bit off the screen here, but that's okay. And then cosine 30 degrees is adjacent. Adjacent is b. b is 5 root 3. 5 root 3 over hypotenuse, which is 10. So you can cancel them out, and you get root 3 over 2. Okay, great. Now for the last one. Tangent TOA, opposite, a, 5 over adjacent, b. b is 5 root 3, 5 root 3. And then we simplified once again. And then remember, rationalize the denominator, so we get root 3 over 3. Okay, let's check our answers. Yay, they're all correct. Okay. Erase all the work. Okay. So just remember SOHCAHTOA, very important. And just try to remember these special triangles. They'll really help in the future. Okay. Okay, now let's look a little bit at trig ratios and exactly what they mean and how they're really applicable. So basically, if you change the side lengths, the ratio of the side lengths will remain the same as long as the angles remain the same. And basically what this means is, as you can see here, this triangle, it's the same, it's proportional to this one. Means the ratio from like this side to this side is the same for both of them. B to C for this triangle is proportional to B to C to this triangle, and AC is proportional to AC, because the angles are the same. As you can see here, there's a little square / rectangle in the corner, meaning it's 90 degrees. And then this is 30 degrees as like it shows. So that means that these are proportional. No matter what the ratios are, they'll be the same. And the ratios, remember, are SOHCAHTOA, sine, cosine, and tangent. And basically, for most trig ratios, we can just plug them into a calculator and find them. Like the ones besides the ones that we were working with, like besides the special right triangles, because you won't be able to know the rest of them off the top of your head. They're like really complicated numbers with a lot of decimal places. So generally best to just plug them into a calculator. And then, but the ones that you should memorize are the ones we'll be talking about, the special right triangles. Okay, so these are the ones in general. It's a very good idea to memorize. So sine 30 degrees is 1/2. And we saw that when you're doing the practice problems as well. You saw that 1/2 kept coming up for sine 30 degrees, even though the side lengths were not the same. Just remember that the side lengths were not the same, and yet the ratios were the same. So sine 30 degrees is 1/2. Cosine 30 degrees is root 3 over 2, which is another one that we saw reoccurring with the special right triangle, where we based everything off of the 30 degrees. We use 30 degrees as a reference angle. And then tangent 30 degrees is root 3 over 3. And sine 60 degrees is root 3 over 2. Cosine 60 degrees is 1/2. As you can see here, they're kind of like swapped around from sine 30 degrees and cosine 30 degrees. Like for cosine 60 degrees, it's 1/2 versus for sine 30 degrees, it's 1/2. And when you think about it, that makes sense, because when you have this triangle right here, what is opposite for 60 degrees, which is, let's label it A, B, C. B would be opposite, right, for 60 degrees, but A would be opposite for 30 degrees. So they seem like they'd be swapped around. And because they're both using the same denominator, which is the hypotenuse, c, as we can call it in this case, it would make sense because cosine 30 degrees would equal to b over c. Sine 60 degrees would equal to b over c too. So then sine 60, cosine 60, they're the same thing. It's because they're just using the opposite sides. Okay, and then for sine 45 degrees, it's root 2 over 2. And same for cosine 45 degrees, it's root 2 over 2. And tangent 45 degrees is 1. And definitely try to memorize these. It'll come extremely helpful in future math. Like, extremely helpful in all your future math classes. Okay, now let's do some practice with these trig ratios that we just learned. Okay, sine A means this over here. Okay, now let's look at some applications of the things that we have just learned. So basically, in robotics, drivers use joysticks to control where the robot is moving, the direction in which it's moving, and all. So the joystick returns an x and a y value for its position, but programmers have to use trigonometry to calculate the angle at which the robot is moving. So they have to use basically, so they know this value and they know this value, because this comes in terms of x and y. Oh, that's really bad. X and y. So that's what they know, but they do not know this, and that's where trigonometry comes in. So let's get some practice. Sihan is driving the robot and moves the joystick to x 4 root 3. The robot moves at an angle of 30 degrees above the x-axis. What is the value of x? I'm just going to highlight some really important things. Oh, that's not highlighting. I'm going to highlight some really important things, and then I'm going to leave you to it. Pause the video and work on it. Okay, let's start reviewing it. Start going through the problem. So we know that it moves to x root 3, right? So we know that, let's draw a triangle first, actually. That's not the right color. Okay. So we know the y value, 4 root 3. And we don't know the x value, which is what we're looking for. What is the value of x? Just highlight that. What is the value of x? And then we know that the angle, the robot moves at an angle of 30 degrees. So basically, the robot moves from here to here at an angle of 30 degrees from the x-axis. The x-axis is just like this thing over here. So let's make it 30 degrees. Okay, now let's solve for x. So think about it. What ratio just involves these values that we have right here? The side opposite to the angle and the side adjacent to the angle. Okay, let me spoil it. It's tangent. Remember, SOHCAHTOA. Tangent equals to opposite over adjacent. So tangent 30 degrees equals to opposite 4 root 3 over adjacent x. Okay, so now let's go through it. Remember that tangent 30 degrees is also root 3 over 3. Now we have this, right? We have this right here. So now let's equate these equations. Root 3 over 4 root 3 over x equals to root 3 over 3. You cross multiply and you get root 3 x root 3 equals to 4 root 3 times 12. Divide by root 3 on both sides. 4 root 3 times 3. Oopsie daisy, you divide by root 3 on both sides. You get x equals to 12. Okay, now let's see. Is that correct? Okay, you see that triangle? Let me just let me just erase all my work here. And we got that the answer was x just write up here, x equals to 12. Let's see whether that's correct. Yes, x equals to 12. So basically what I did was I used the ratio that I knew. I knew that tangent 30 degrees, no matter what, equals to root 3 over 3. And then that, you can just simplify from there. So tangent 30 degrees equals to, and you know that tangent 30 degrees also equals to 4 root 3 over x. That has your variable in it, and that's what you equate to. The answer key kind of solved it in a different way, but you can also solve it like how I showed you, 4 root 3 over 3, not over 3, over x equals to root 3 over 3. This is the ratio that we know, known ratio, and this is the ratio that we're not trying to find this ratio, it's more like we're trying to find the variable. So variable. This is the ratio that we've been kind of given to work with. Okay, now let's look at another application, trajectory following. So in our software program, we use trigonometry to plan and follow a route from one point to another. Using simple trigonometry, we use the angle of the robot called the heading, and the robot's current position to predict where the robot will be after moving a certain distance. And we use that value to adjust our movement. Okay, so this is like where the robot is going. This is like the travel. And then, okay, yeah, let's look at a problem first. Okay, so Saranya, I'm driving the robot from 3, 5 with a heading angle of negative 50 degrees, and I move up 6, driving the robot from 3, 5 with a heading or angle of negative 50 degrees and moves up 6 units. Where does the robot end up? Answer with an ordered pair. An ordered pair just remembers x, y. Okay, let's just draw a quick graph. Okay, so 3, 5, 3, 3, let's put this as 5, 5 over here. Okay. And an angle of negative 50 degrees. Negative 50 degrees just below. So about here. And I move 6 units. So that basically means the hypotenuse is 6 units. So where does the robot end up? So we have to find this right here. This does not mean that where you end up is 0, 0 or the origin. It's just the way that I drew it. And here, this is a better way to draw it. Actually, it's like a little flipped around, but it's fine. Okay, we can use this as well. So we need to find x and y. We know one side length, which is the hypotenuse, and we know the angle. So in this case, you also do need a calculator. So I'm just going to grab my calculator. Okay. So let's see. So we have the angle and the side length, as said before. So to find these two values, x and y, you can't really use tangent, because tangent just involves opposite and adjacent, and we don't have those values. So we don't have anything to work with, especially since we do not know the ratio for tangent 50 degrees. So we have then two other ratios to work with. Cosine 50 degrees, which equals to adjacent x over hypotenuse 6. So you just simplify this out. Isolate x. You multiply both sides by 6. And you get x equals to 6 cosine 50 degrees. So let me just plug that into my calculator, and let's see what do we get. 6 cosine 50. Okay, so that equals to 3.857. I'm rounding that, by the way. So that's our x value. And now let's look at the y value. So sine 50 degrees equals to opposite. Opposite is y over hypotenuse 6. So we multiply both sides by 6 to isolate the variable. And then we get y equals to 6 sine 50 degrees. And y equals to, let me figure that out as well. Sine 50 degrees equals to 4.596. Okay, so y equals to 4.596, which is 6 times sine 50 degrees. So our ordered pair would be 3.857 and 4.596. Now let's check our answer. Great, that's correct. And as you can see, basically use the same way as I did. We found the ratio that we needed to use, in this case sine and cosine, and then we just plugged in the stuff that we knew and we left the stuff that we didn't know alone. So we just left those as variables, and then we just isolated the variables, plugged it into our calculator, and then that was there. That was all we did. But that's also not where it ends up, because that's how much it moved. Actually, yeah, so basically this is how much it moved. That's the distance it moved. But then we need to calculate from 3, 5. So the original x value we have is 3, 5. The original order pair we have 3, 5, and then the next one is then we moved over, let's see, 3.857 units. So that would be approximately 6.857. And then we also moved down from 5, 4.596 units. So then that would be 5 minus, that would be 0.404. And that's the correct answer, actually. Sorry, that was my mistake. I forgot that we started from 3, 5. So just always remember also from where you're starting at. And don't just plug in the x value, the x and the y value that you get, because that could be just the distance. That is the distance. That's the distance you traveled. Not the distance you traveled. That's like the sort of like trigonometric path with which you traveled. But that's not where it ends up, because you start from 3, 5. So that's your final answer, 6.857 and 0.404. As you can see here, I also made that mistake, so just remember it. Okay, let's do another practice problem with trajectory following. So, Zenith drives the robot from -1, 2 to 3, 6. Find the robot's heading. Remember, the heading is the angle. So, here's a quick diagram. You go from -1, 2 to 3, 6. And you can find the x and y values from this as well. So, I'm going to leave you for a second. You go and try it. Pause the video and all. Do whatever you have to. Then I'm going to review it. Okay, let's start reviewing it. So let's start with finding the x value. So we first start with the original x and then our final x. So -1 and then 3. So we move from -1 to 3, so we just do -1 minus 3, just do -4. But in this case, we take the absolute value, or we just take like how much distance it traveled. Actually, wait, that's not, okay. So then, actually, let's look at it this way. So you go from -1 to 3, right? So you're just going like this. And we're just looking at the x path right now. That means you moved over 4 units, because you moved over -1 to 0 and then 0 to 3. If you just think about it like that, it's a little bit easier that way to visualize it. So that equals to 4. And then you also moved up from 2 to 6. So that's another 4. So basically what you have here then would be a 45, 45, 90 triangle, because 2 of the sides are the same, and it's a 90-degree angle right there, right? So then you can immediately tell that whatever ratios you get for sine, cosine, tangent, no, you can tell like that since the sides are the same, the angles have to be the same as well. So then the only way for the angles to be the same is if you use the property that all the angles inside of a triangle add up to 180 degrees. You already know that one is 90 degrees. So you do 180 minus 90 is 90 degrees. And then you have 2 angles, right, that you're trying to solve for. The thing is, you can solve for both of these because, as I said again, the side lengths are the same. So that means the angles have to be the same. So you just divide by 2 and you get 45 degrees. the robot's heading, or theta, the angle, is 45 degrees. There. That's basically all we do. And in fact, you can actually use inverse tangent on this as well. So you can use the tangent ratio. And basically, you can do that by, so you know the tangent theta is the angle you're looking for, is opposite over adjacent, TOA. So opposite is 4, adjacent is also 4, so you get 1. And then if you remember from the ratios that we talked about earlier, the special ratios, the ones that you should definitely memorize, tangent of theta, if tangent theta equals to 1, the angle has to be 45 degrees. Just another way of approaching it. Okay, so thank you so much everyone for watching. If you have any more questions about what we talked about in this video or any other videos that we have, feel free to DM us on Instagram at missionmath.com, mission.math, or at Sushi Squad FTC. Okay, thank you all again.